So talking about entropy basics. So first, entropy is a thermodynamic state function that describes how dispersed a system's energy is. So in case you don't know what a state function is, make sure we go back and we review that information, but it has to do with if the steps within the process actually impact the overall change or if it's just the initial and final difference that makes an overall difference. So if you're not quite sure, go back and look at your notes, but entropy can be used to determine if a reaction will be spontaneous or not. So typically a higher entropy is more favorable and a lower entropy is less favorable. Remember, in nature loves randomness. In this case, it's going to move towards randomness, so higher entropy is more favorable, lower entropy is less favorable. So a positive delta H indicates that the reaction is therefore spontaneous. So higher value, more spontaneous. Moving on here, we can predict the side of our entropy. So it is going to go towards our random. So here, if we're changing from a gas to a solid, do you think your randomness is going down or is it going up? In this case, if we go from gas to solid, it's going down. So our sign for our entropy is going to be negative. Also, for the second one, you have 2 moles of a gas turn into 1 mole of a gas. So is the system getting more random or less random? It's getting less random, so the sign will be negative. Third, we have 2 moles of liquid and a mole of gas turning into solid. In this case, we know that solid is less random, so it's negative. We have 1 mole of solid turning into a mole of aqueous and a mole of gas. So that is going to be more random, which is positive. We know that it splits into 2 moles, and those moles are more random than a solid mole would be. For a third, we have 2 moles of H2, 1 mole of O2, go to 2 moles of H2O. So we're going from 3 moles of gas to 2 moles of gas. That means that the system's getting less random, which means it's going to be negative. So last slide on the theory, which has greater entropy? Based on this, which has greater entropy, which one has greater randomness? Those words are easily interchangeable. So in this case, we know temperature, the more kinetic energy you have, the more random you're going to be. So a higher temperature is going to be more random because we're increasing our kinetic energy. So then volume, smaller or larger volume, which one is more random? Think about a balloon. If you have a balloon that is super small or a balloon that's really big, which one is going to have more randomness? The larger balloon, right? Because it takes up more space and there's more possible positions for those molecules to take up instead of just in a smaller area. So if you have moving particles, do you think more or less will increase your randomness? That's also going to be more. Think about your various states. So as the number of your particles increase, there are more particles that can contribute to that randomness. There's more states available. State of matter, solid, liquid, or gas. As we talked about before in our energy signs, gas is going to have more kinetic energy than liquid or solid, respectively. So then entropy increases with the freedom of your motion of molecules. So in this case, gas will be greater than liquid, will be greater than solid. So this was a super quick review about entropy basics, but hopefully it gave you a little bit of a better grasp on